Hello and welcome back to my channel. In today's session, we will look at top 15 interview questions that you can expect as part of your Python. Now, this is specifically from a DevOps interview perspective. So, if you have attended any DevOps interview or if you're planning to attend any interview, then uh, definitely, they will ask if you have any experience with any of the scripting language. Could be your shell scripting, PowerShell scripting, or Python, or any other shell scripting. Sorry, any other scripting languages. So in this particular session, I will be covering the top 15 questions that you can expect as part of your Python for DevOps. All right. Now, these questions are mainly designed from a basic perspective or the top 15 that you can expect, and we'll also look at the detailed answers for each of these questions. Once again, before I start off with the session, please don't forget to hit that subscribe button. So let's get started with this. The first question we have is, how do you manage package dependencies in a project, in a Python project? Now, any project we take, managing the dependencies of the project is very critical, right? So, managing the dependencies will ensure that your project will run smoothly across different environments, all right? Now, the most common tools that we can use to manage your package in Python is your pip, which is your Python's package installer. So, with this, we'll have to basically create a requirements.txt file. So, for this, we can use the pip freeze command, which will basically create your requirements.txt file, and this will list all the projects that your project depends on, along with their versions. So this will basically capture the current environments packages that are installed and what are their respective versions, and then we can start installing the dependencies. Now, to install the dependencies, we can make use of the pip command. So pip install -r and then the requirements.txt file name. So whenever you're setting up your project on a new machine, that contains your Python project, you have to make sure that that machine has all the necessary packages. So this command will ensure that the environment has all the packages that we have specified in the requirements.txt file. And for any complex dependency management, we have tools like pipenv or poetry that can be used. So pipenv will automatically create and manage a pip file and pipfile.lock for your project, providing your deterministic builds. And poetry provides a similar functionality but with more features like project management, dependency resolutions, and so on. The next question we have is, how do you read and write to a file in Python? So, file handling is something that we can definitely do in Python. So, reading and writing from your files, these are very common tasks that we do in Python, and we can accomplish this by using the built-in open function. All right, so here this is an example for reading from a file. So this with statement will ensure that the file is properly closed after we have done working with that particular file, even if there's an exception that is raised. So in this case, what we are doing is we're opening this file.txt in the read mode, and then we are reading the content of the file, and then we are printing it out. Now, if you want to write to a file, we can use the open statement, but then we will be using this write, so w, which indicates that we want to write. And if you want to append, we can simply use the a mode, so file.txt and then a, which will append to the file, which is basically maintain the existing content and add to it, whereas write will delete the existing content and then write the data to the file. The next question we have is, explain the use of __ init __ .py in Python. So this is basically an integral part of your Python's package system, and this is used to mark any directories on your disk as Python package directories. So if you have a Python directory which contains all your packages, and if you want to mark that directory as Python package, we can make use of this script basically. So here, for example, within the my underscore project, I have this my package, and I can mark this directory as a package directory. So why is this important? So one, we can use it for package initialization. So when we import a package, the init script file in the package directory is executed first. All right, now this will allow you to initialize your code for the package, and then we can also make use of it for the namespace management. So the presence of this init file makes it clear to your Python that the directory where this file is present, it should be treated as a package. And this allows you to import statement to basically import your modules from this particular directory. So here in this case, from my package import module 1 or import module 2. So this file makes your Python treat this directory as a package. So the init file can be empty, or it can contain the initialization code for your package. The next question we have is, how do you handle exceptions in Python? So for this, we can make use of your try blocks. So handling the exceptions in any programming languages, right? It's very important, right? And this ensures that your programs can gracefully manage any unexpected errors that we might encounter. So in Python, we can make use of your try block. So we have the try, we have except, we have else, and then we have the finally block. So the try block will contain the code that might raise an exception. So in the try block, we are giving the logic, what exactly you want to do, and this might raise an exception if it does not execute as expected. Then you have the except block, which is used to handle the specific exceptions that we might get in the try block. You can catch multiple exceptions if you want by specifying a tuple of exceptions. Now in this case, I'm only capturing the zero division error. So when I run this code, if I get a zero division exception, then my except will execute. The else block, on the other hand, runs if the exceptions were it. So I'm telling, try to execute this code. If there's an exception, I want you to execute this particular code. And then I have the finally block, which will execute always, no matter exceptions were raised or not. So that's why the name finally. All right, so try executing this code. If there's any exception, raise the exception, and if there's a if there's no exception, then trigger the execute the else statement. And then finally, once you're done executing all of these things, I want you to finally execute this statement. The next question we have is, how do you use environment variables in Python? So environment variables can often be used to set your configuration settings, or basically configure your secrets for your applications without hard coding them, right? Now many applications we take hard coding is not really a good practice. We should never be hard coding any data, and that's where we can make use of your variables to store this data, and then we can call those variables within our code. So one option we have is using the OS module. So we will be declaring these variables on the machine, on the local machine, and then using this OS we will be reading those variables. So db host and then the db port, and then we can export them. So if you're on the Linux machine, we can use the export command, and then we can export the variable name and the respective value. And if you're on the Windows machine, we can make use of the set command. You can also make use of a .env file where you can store all these variables, and then we can call those env file within the script by doing an import. All right, so either we can store them as variables, or we can store them in a file itself, .env file itself, and we can start referring this within the script. The next question we have is, explain the concept of virtual environments in Python. So virtual environments can be used when you're working with multiple projects and you want to maintain isolated environments for each of these projects. We can make use of your virtual environments for this. So essentially what happens out of this is, each of the project that you will create will have its own dependencies, which are independent of other projects and other dependencies. So if you want to create a virtual environment, you can use this command. So this will create a virtual environment for us. This is on the you can use either on the Linux machines or on the Windows machine. And then to activate that virtual environment on the Windows machine, you can run this command. And if you're on the Linux machine, then you can run this particular command. So this will activate the virtual environment for us. Now this can be useful when you want to avoid version conflicts between the dependencies. So maybe one project needs 1.0.0 and the other project needs 1.1.1. So we can avoid that conflict by making use of your virtual environments. And then at any point, if you want to deactivate the virtual environment, you can just run this deactivate command. Now, what are the benefits you get out of this? One, you can isolate your dependencies, making sure each of the project has its own dependencies. You can no administrative privileges are required, so you don't need any admin rights or any root permissions, and very easy to replicate the environment. So using tools like requirements.txt, you can easily replicate the exact environment on another machine. The next question we have is, how do you execute a shell command from within a Python script? So whenever you want to execute any Linux commands, any shell commands from your Python script, you can make use of the subprocess module in your script. Now this module will allow you to spawn any new processes, connect to their input or output or error pipes, and also obtain the return codes of that subprocess. Like in this case, I'm running this ls-l command. So I'm using this subprocess module to run this particular command, which is a Linux command for me. Now I'm using this subprocess.run, which is used to basically run the command that we have described within the arguments. I'm also giving this capture underscore output, which is to capture the standard error and the standard output, and then text equals to true will return the output as a string instead of bytes. And then I have the return code here. So the result, from this result, I'm looking for the return code, and if the return code of this command is 0, that means my command executed successfully. If anything other than 0, I'm telling that the command has failed. The next question we have is, what is the use of the with statement in Python? So the with statement can be used whenever you want to handle your files and manage the cleanup tasks as well. So this will simplify your exception handling by encapsulating common preparations and cleanup tasks in the so-called context manager. So this will ensure that the resources are managed properly. For example, opening up files, closing the files, all those things can be managed properly. So with this, the advantage you have is you get a proper resource management. So files are closed automatically. So with this, we don't have to explicitly close the file. Once we are done with the operation, the files will be closed automatically. Makes the code more readable and very concise. Then reduces the boilerplate code and the risk of errors. The with statement can be used with any object that implements the context manager protocol. So basically any protocol, any context that has the enter and exit methods, we can make use of your with statement. But mainly we use it with your file handlers when you want to work with your files, reading the data from your file, adding the data, modifying the data, and all those things. We make use of your with statement. The next question we have is, how do you connect to a database in Python? So for this, we'll need to essentially open up a connection to the database. So we have libraries that are available for this. So if you're using SQLite, we have SQLite 3. If you're using PostgreSQL, we have a library for that. And if you're using MySQL, there's a library for that as well. So depending on the database that you're using, you will be using the respective libraries. Now in this case, we are trying to connect to SQLite 3. So first we are using this connect over here to establish a connectivity to the database, and obviously you'll need to give the credentials and all. And then we are creating a cursor, which is to basically interact with the database. So here, so first establishing a connectivity, and using that connectivity, we're creating a cursor. And then we are running execute, which is to execute the SQL statement. So here, cursor dot execute, and then the SQL statement that you want to execute. And then finally, we are doing a commit here, which is to basically save those changes to the database. And then we are doing a fetch all, which is to get all the results of a particular query. So here, if you see, we are executing this, and then commit, which is to save or rather execute and make the necessary changes. Likewise, we are again inserting some data, and we are saving those changes. Here we are reading the data, and we are telling it to fetch all the data from the database. And then finally here we are closing the connection to the database. The next question we have is explain the use of decorators in Python. So decorators is a very powerful tool that you have in Python with, and we can make use of this to modify the behaviors of your functions or methods. So let's say you have a function or a method, and if you want to control the behavior of those functions or methods, we can make use of your decorator. So we can often use them for logging, access control, instrumentation, and many more. So your decorator is another function that we will be defining, and this function takes another function and extends the behavior of that function without making any changes to the code of that function. So essentially here you'll have a base function, and then you will have a decorator function, and using this decorator function we can modify the base function without making change to the code itself. All right, so here I have an example. So here we are creating a decorator function that wraps the original function, which is your say hello function. All right, so here we are defining a wrapper. Now the wrapper here, that's basically your nested function that adds behavior before and after the original function call. So here this is your before calling the function, and then we are calling the function, and then after that post calling the function. Okay, so at my decorator, so this is the decorator syntax that applies the my decorator to the hello function. Okay, so when this hello say hello function is called, it actually calls the wrapper function, which includes the additional behavior defined in the decorator function. So though we are calling this function, because of the decorator we are changing the behavior of this function without making any changes to the code itself. Okay, so that's where we can make use of your decorator. The next question we have is, how do you perform unit testing in Python? So unit testing can be done by making use of the unit test module in Python, which is part of your standard library. So this module provides all the necessary frameworks that we can use for writing and running our test cases. Okay, so here is an example. So we are importing the unit test module. So first we are creating a test case. So base class, which defines the test methods, and then we are using this test add function or the method to check the addition function, the add function. So self.assert equal, so this is the method used to check for the expected results, and then unit test.main is the entry point to run these tests. Okay, so by running this script we are making use of the unit test framework, which will discover and run the test methods and reporting if there are any failures. So here basically we are checking these additions, and we are calling the unit test module to run these test cases for us. The next question we have is, how do you handle configuration files in Python? So configuration files are basically used when you want to manage the settings to your application in a more structured way. So Python provides us with a module which is your config parser module, and this module allows us to read and write the configuration files which are in the ini format. So here I have a sample configuration file which is in the ini format. So I have the key and the respective value. And then by making use of the config parser, we can read the data from here and use it in the subsequent code. So to explain this, we are using the config parser, which basically creates a object for the configuration parser, and then we are reading the config.ini file, which will start reading these configurations. And then we have this config section and the key, which is used to access the value from the configuration file. So in this case, we are trying to get the data for the value for the DB host. So we are trying to read the config file for the database section, and within this section we are looking for the host key, and we'll get the respective value for it. So this method will allow your code to be clean and also separate configuration from logic. So we don't have to put this configuration within the code itself. We can maintain it in a different file, and then we can start parsing it using this module. The next question we have is, how do you manage processes and threads in Python? So Python provides us with a threading module for managing the threads, and then it provides us with multiprocessing module for managing multiple processes. So here is an example for your threading. So first we're importing the threading module, and then we are creating a function over here, and we are creating a thread over here. So thread which creates a new thread that runs the print numbers function. Okay, so we are starting the thread, which will essentially start the thread. Join, which will wait for the thread to complete. All right, so we have defined the function here, and then we are creating a thread over here by using this threading module. And if you're talking about the multiprocessing, we are using the multiprocessing module over here. So we are creating a multiprocessing process, which is again calling this print numbers function. So it creates a new process which runs this function. So we're using the start to start the process, and join to wait for the process to complete. So threads are lighter and they share the same memory space when we are using the threading module, and this can lead to issues with data consistency. Whereas processes, on the other hand, are heavier but provide separate memory spaces, which can avoid issues like your data consistency. The next question we have is, how to use argparse to handle command line arguments in Python. So argparse module can be used when you want to write very user-friendly command line interfaces using Python. So this will basically parse the arguments and generate help messages automatically. So it's basically, if you want to accept arguments from the command line, we can make use of this module. So here we are importing the module, and then using that, we are creating like a command line interface. So argparse.argument parser, so we are giving it a description. We are creating an object with your description. Then add underscore argument, that's basically the what do you want to accept, or what arguments you want your Python code to accept. We are defining that. And then parse args, that's basically parsing the command line arguments. And then accumulate is uses the parsed argument. So whatever the arguments that we are getting from the command line, that will be used over here. And then if you want to run this from the command line, we'll basically call the script, and then we pass the argument and what do you want to do. Okay, so here, so we are integers, so basically we're getting the integers, and then sum, which will basically do a addition of these numbers. Alright, so this way we can get the arguments from the command line and then process them in a Python script. The next question we have is, how do you handle JSON data in Python? So for this, we'll be making use of the JSON module, which can be used whenever you're working with your JSON data, like, maybe you want to read the JSON data or get the data from your JSON. We can make use of your JSON module. And this is something very commonly used data across your web applications. So here we are using this JSON.dumps, which is to serialize the JSON string. So we are creating an object for the JSON string that we have here. And then JSON.load will deserialize your JSON string to a Python object. Then we have JSON.load over here, which will start reading the JSON data from your file. So there are different ways that you can work with your JSON data. All right. Then you have the JSON.dump. So you can see the difference here. So we have dumps, and then we have a dump without s, and then we have loads, and then we have load without an s. So the dump without an s is used to write the JSON data back to a file. So if you have any JSON data, you can put it back as well. So these methods will allow for easy conversion between your Python objects and JSON, making it very simple for us to handle the data in web applications or any configuration files. And that brings us to the end of our top 15 interview questions that you can expect as part of your DevOps, as part of your Python for DevOps interview. If you found this video helpful, please don't forget to give it a thumbs up, subscribe to the channel, and hit the bell icon to stay updated with our latest content. Thank you for watching, and I will see you in the next video.